All right, we're going to start by doing problem number 20 in the textbook. So what we have over here is use reference angles to evaluate the expression. We have the cosecant of 11 pi over 6. The cosecant of 11 pi over 6 is over here. And remember, this is almost 12 pi over 6. Right? It's almost 12 pi over 6, but it's missing pi over 6 to get there. 12 pi over 6 is 2 pi. So this correlates to almost 2 pi. Almost 2 pi, but then we're missing pi over 6, which is 30 degrees. Our angle looks like this. That was really bad. Our angle looks like this. 11 pi over 6. And the reference angle is pi over 6. So we can draw a triangle. Pi over 6. This is one of our special triangles. Short side, long side, hypotenuse looks like this. We're going down, right? We're going right, and we're going down. So the x value is positive, but the y value is negative. Or you can always think that all squids train camels. But either way, cosecant is going to be the reciprocal of sine. So sine is negative 1/2. Cosecant's that reciprocal. Sine of 11 pi over 6 is negative 1/2. Cosecant is that reciprocal, negative 2. And that's all there is to it. That's all there is, negative 2 it. All right, never mind. Let's do the next one. Let's look at 38. So 38 says, if sine of t is 3/4, and then t is in quadrant 2, find the other 5 trig functions. Okay? So we need the cosine of t, tangent of t, cosecant of t, secant of t, and the cotangent of t. So we're going to draw a little picture. Okay? 2 ways of doing this. You can either draw a picture and do it like we did the last problem, or you can use a Pythagorean identity. You draw a picture. I don't know where it is. Let's just draw somewhere in the second quadrant. Right? It's in quadrant 2. But whatever it is, this is t. And we have some triangle that looks like this. Okay? Some triangle that looks like this. And we know the opposite over the hypotenuse has this ratio, 3/4. We're going left and we're going up. So this is a positive value. And this value down here is a negative value. Or you can think all squids train camels, or which value is positive in which quadrant. We can use the Pythagorean theorem to find out what this number needs to be. So we're going to say that something squared, you can call that x squared plus 3 squared equals the hypotenuse squared. And just solve this. X squared plus 9 is 16. X squared is equal to 7. X is plus or minus 7. And again, we're using negative 7 because we're in the second quadrant. We're going to the left. The x value is negative in the second quadrant. Right? X is negative in the second quadrant. So what do we have? Well, now we can fill in all of these things. Cosine is adjacent over hypotenuse. Wait a minute. Whoa. Jason, what are you doing? So here's how I noticed I made an error. The hypotenuse always has to be the longest side. 7 is way too big over here. There's a little funny business going on right here. Plus or minus the square root of 7. Okay, so x is negative square root of 7. Whew. So cosine is adjacent over hypotenuse. That's going to be negative square root of 7 over 4. We're expecting cosine to be negative in the second quadrant because sine is the only thing that's positive here. Tangent, opposite over adjacent. That's going to be negative 3 over the square root of 7. You don't have to rationalize the denominator here. And for the last three, just reciprocate. So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. You don't have to rationalize the denominator for me. And then cotangent is a reciprocal over here. And these are our answers. All right, let's do two more. Do problem 62, 76. If you look at 62, what are we doing down here? Use identities to evaluate the expression. Oh, interesting. All right, so for 62 says, if tangent of t is approximately 2.7, I definitely wrote 7.2, approximately 2.7, and sine of t is approximately 0.94, what is cosine of t? So we need to relate these three quantities. How can we relate sine, cosine, and tangent? So look back to your trig identities. Recall that tangent, okay, this is what we're looking to find, right? Tangent of any angle is the sine of that angle divided by the cosine of that angle. That's what we need here. Something to relate these three things, and this is the tool that we have. Pythagorean identities would be the other guess, but Pythagorean identities don't include tangent, unless you use one of the weird ones. So let's write this down. If we use this, right, then tangent of t, actually, let's not even move it. Let's just do it right below. What is tangent of t? It's about 2.7. What is sine of t? About 0.94. What is cosine of t? I don't know. I don't know. But we can sure as heck find out right here. Solve for cosine. Hey, there we go. So we have cosine in the denominator. So to get cosine out of the denominator, if your variable's ever in the denominator, multiply both sides by the LCD. Multiply both sides by the denominator, because now on the right-hand side, that cancels out. And on the left-hand side, we just have 2.7 times cosine of t. All that's left is to get cosine by itself. And we're going to get that the cosine of t is approximately 0.94 divided by 0.27. And 0.94 divided by 2.7. Oh, come on, Google, don't let me down. Is about 0.3481. Let me just make sure I type this in right. 0.94 divided by 2.7. Yeah, 0.3481. And actually, hold on. The other two are rounded to 2 decimal places. Let's round this one to 2 decimal places too. 0.35. And if we really want to be good, let's check our answers. Right? Tangent of t is sine of t divided by cosine of t. Is this about 2.7? Whoa, dropping everything. Let's check it out. 0.94 divided by 0.35 is approximately 2.69. It's close. Yeah, it rounds to 2.7. Whoops. Check. All right, there we go. Let's do one last one for this video. Problem number 76. So we control F, 7, 6, period. It jumps right to it. The height of a piston, H, can be modeled by the equation y equals, or H equals, y is H in this cake. Oh, I'm hungry, I want a cake. In this case, y equals 2 cosine of x plus 5, where x is the crank angle. So find the height when the crank angle, when x is 55. All this wants you to do is plug in 55 degrees per x, or convert it to radians and plug it in radians. But the really important thing is that whatever you're doing, you know what you're doing. Okay? So if we type this in, 2 times the cosine of the angle, what's the cosine of the angle? 55 degrees. Or convert it to radians. Plus 5 is going to be 6.15. And that's going to be our answer. And let's just make sure we have the right unit. 6.15. We should write it out, right? Let's just write out the whole thing. Right? It's H is going to be 2 times the cosine of x. It's 55 degrees. Plus 5. Type that into a calculator. We got 6.15. What are our units here for number 76? The units are inches. All right. The height of this piston is going to be about 6.15 inches. And that's all there is to it. Hooray! Thus ends many videos. Bye-bye, good luck. Let me know if you have questions.